The next part is looking at scores. Right? So exam 1 statistics. Right? Each semester it's a derivation off the same exam. So older versions were 67 and 69%. I think last fall was a 66%. This semester we average in at a 68%. Okay? Not the highest, definitely not the lowest, right in the middle of that. That's pretty solid. Okay? So I'm okay with that. Everybody else may look at that and say, well, that is then what letter grade? A D. And that is because you have been brainwashed into a crap grading system. That is the average grade. That makes the average grade a C. Average is C. That's what the letters mean. Anybody telling you anything other than that has no idea what a grading system is. Okay? They're literally just making stuff up to make their life easier. Okay? What is the best exam average? Ooh, that's a tricky question. What is the ideal exam average? And I don't want a letter grade, so I'm mouthing B. Okay? I want percentages. So here's 75. Everybody agree? 75? The ideal exam average is a 50%. That, by definition, is where your exam average should be. Okay? Why? That gives every student equal opportunity to distinguish themselves from every other student. If you have an exam average of a 75, the student that knows everything versus the student that knows most of the things have the exact same score. They can't distinguish each other from each other. Right? If you have an average at 50%, everybody can distinguish themselves from everybody else. Right? That's the point of an exam, is to show who knows the material and who does not. And for those of you that say, well, that's completely ludicrous. Okay? Let's just say we don't distinguish between what people know or don't know. Okay? I have never been to med school. Guaranteed. Your doctor probably has. Who do you want to talk to for medical advice? If we can't distinguish my knowledge from their knowledge, I can diagnose you just as well as that other doctor. Do you think that's a problem? Okay. And if you're saying, no, I'm not a good doctor, okay, you do not want me diagnosing you. Okay. We want to be able to distinguish different abilities. That does not mean I am now a horrible person. That just means I'm a horrible doctor. Okay? But if that same doctor was dropped into this class to teach chemistry, they would probably fail abysmally. Okay? So we're trying to distinguish each other away from others so that we can move into fields that best suit us. That's the point of an education. Okay? Not only to distinguish, but then to give you the opportunity to learn that material and decide, was that part of your natural talents? Okay? If it's not part of your natural talents, but it's part of your desire, right? Believe it or not, the desire gets measured in when you think about med school. I just picked med school because a lot of people want to go there. Okay? How is the desire measured in? Is the only thing that allows you to go into med school your GPA? No. What else do they look at? Okay. Internships. Okay. Volunteer hours, charity work. Okay. They look at other things because what are they testing for? Not just your natural ability, but your desire. If you have a great natural ability to be a doctor, but you don't want to be a doctor, you're just going to kill people. Okay. That's not a good doctor. Okay? So they'll try and find a different space for you. Okay? And that's a lot of what we're trying to work through and do. Okay? So back to this, how would we look at and assign grades? Number one, we don't. Really? Yeah, we don't assign grades based on this. Because I'm going to guarantee you, these people down here are going to be really upset if I assign a letter grade for this course on this single exam. Right? Did they do something else to learn the material? Maybe they did nothing else. Okay, we can talk about that too, but did we have homework? Yeah. So they're working towards it, potentially. They're doing that homework. Are there other exams? Is there more content? Yeah. You don't want to go into a class where it's all based on a single grade. Okay? A lot of people have an issue with that. That's why we spread out and do multiple grades. We do multiple assignments to test your varying abilities in different tasks. Right? An exam is a single high-stress environment. Right? Lots of people crack under that pressure, particularly without a lot of practice. Okay? So we don't do it based off of a single exam. Okay? But you probably want to know how you did. Okay? Well, here's the easy way. The average is a 68%. How'd you do if you got an 80%? You are 12% above the average. The average grade is a C, okay, set roughly at 75. 12% above that would be an 87%, which would be, in your weird grade scale system, a high B. Add to that fact that you probably did the homework, and you now have a perfect score in the homework. Your high B is now probably an A. So when you look at an exam, the average is one of those big indicators that help you look at this, okay, and help you assess how you're doing in the course. Okay? If you are under that average, okay, well, is that where you were aiming? Yes, then fine, you're doing exactly where you wanted to be. Okay? If you don't want to be under the average, then you need to change how you approach the class. Okay? And that's fine. It's the first exam. This score, right here, let's pick this, 38. Does this score permanently affect your grade? We're seeing some yeses and seeing some nos. Absolutely not. It has zero effect on your grade. What? Why not? Because that person is going to go back and say, wow, I messed something up. I'm not understanding what's happening here. This could be my fault. It could be Mike's fault because he's not teaching me the way I want it to be done. So I'm going to go talk to Mike and be like, hey, Mike, these are things that I need. Okay? I'll work with you, and if I can offer you those things, I'll do it. Okay? Maybe I didn't read the book ahead of time. I'm not doing the homework. Maybe I should start doing the homework. Okay? Those are some big adjustments. Okay? Those are actually really massive adjustments. So when exam 2 hits, what should happen to that score? It should go up. What if it stays the same? Something's not really working. Okay? Now we've got a score that sticks. Okay? Why is the second one stick but not the first? But we're saying we get the exact same answer. Why does one of those exams stick but not the other? The final exam is a resurrection final. Meaning you screw up once, you now have that wake-up alarm. Whoops, I screwed up, now let me fix it. Fix your mistake, that exam disappears. Don't fix the mistake, it's now permanently stuck because you can replace one exam with the final. And only one. Everybody has a bad day. Getting 3 bad days, unfortunately, is horribly bad luck, and that's just going to suck. Kind of make sense? Hi. So, how do we determine an actual course grade? Well, the course grade would be something like this. Notice what happened to the average. We went from a 67%, 68% to a 74%. Why would it go up? Why would the course grade go up when we look at the entire course as opposed to the exam? What's that? There were other assignments that you have completed. Of course the course average is going to go up because most of those assignments were just completion. Did you finish it? Did you submit it? Your score goes up. Okay? There are some cases where it went down. Why did that happen? You didn't do it. Okay? So now you're doubly hurt because you did poorly on the exam and you didn't do the simple stuff to help your grade move forward. Okay? That's really bad. We need to fix that. Okay? What we look at now, or what I look at, is this then spread for the course. Okay? And what you should be seeing is a rough bell shape. Okay? It's not a perfect bell curve, but it should, in theory, be. This looks more kind of like a slope, like this. Okay? Which, as far as you're concerned, is a really good thing. Why is that a really good thing? Where's the majority of the class? At the higher end, which means you're all getting higher grades. I mean, really, in all honesty, you're going to sit there and tell me, I want to learn the material instead of getting a higher grade. Some people do, that's fine. Those are cool people. I like you. Everybody else, you're understandable. You're not cool, but it's understandable. Right? The majority of the class is grasping the material or at least getting a higher grade. We do have this section down here. This is the section I am primarily concerned about. Okay? That is actually roughly C lower that I care about. Because the people above there, you're already doing fine. Okay? Some of you can do better, that's okay. Okay? But it's these people. Figure out what you did. Okay? We've had multiple now quiz questions asking about what you did to prepare for the exam before the exam, and then saying what you did to prepare for the exam after the exam. Because sometimes your opinion changes. Okay? Think about what you did for the exam, how you can change and do better. Kind of make sense? As far as assigning grades go, usually what I try and find is do a histogram like this and find sections between grades. These bottom two students deserve a lower grade than this guy. Why? Because there's a 20-point gap between them. Right? So if I can find gaps in the grades, that's where I tend to drop grade breaks. And they usually hover close to the 90, 80, 70 cutoffs. Okay? For the most part, it's usually 88 and above is an A, 78 and above is a B, that kind of stuff. Because the average usually sits about a 75%. Okay? Kind of makes sense? Okay. Last thing I want to do. So we've got this weird thing called sum stats. So I went through and said, okay, well, if, and for this one I actually said 89 and above was an A. So these were the A people. These were the B. These were the C. And I don't distinguish between D and E, because as far as I'm concerned, they're the same grade. And we've got some kind of random numbers associated with them. Any idea what those random numbers are? Percent of your grade that you have accepted that you do not want. So I give you 100%. The people that are getting A's, those people are saying, actually, 5% of that, I don't need. I will accept that as 0 credit. Okay? Really what that means to me is that you think you are that good, you don't have to do the busy work. Okay, some people are that good. Okay? There's a little 0 next to it. Any idea why there's a 0 next to it? Because if you look at the students that are in that category, only 2 have not done the busy work. Everybody else in the A category has done all of the homework. So they are saying, I want every last possible point. The 2 people that haven't done all the homework, okay, and this is where they might go, woohoo, I'm an awesome person, okay, are either so egotistical that they have decided they don't need to do that work, okay, or they're that good. Okay? There are people that are that good, okay, and that happens. The issue is that humans think we're exceptional, and every single person in this classroom thinks they are that good. Even these 2. Okay? We have false assumptions about our ability. This is only the first exam. I would argue those 2 people could very easily be in a wake-up for the second exam or the third exam, and they should start doing the homework. The rest of the people in the A category said, give me every last freaking point I can squeeze out of you. Cool. People in the B category said 2% of the grade I don't want, just get rid of it, I don't want to see it. Okay? So now the highest you can get in the class is a 98. That's actually not too bad. Okay? The C category, 4%. The failing category literally came in and said to me, with this score, literally said, the highest grade I want in this class is an A-. I want to squeak by with an A. Okay? I don't want to see 7%. I'm going to say, you know what? I am so good, I'm not accepting that 7%. Okay? That's okay if you're at the other end of the category. You're not. You're down here. Okay? You're not that good. What should you immediately change? Do the homework. Okay? Get that improved. That's just points. Those are saying, well, it's just points. It's not a big deal. It's just busy work. The people scoring higher did the busy work. The people scoring lower did not do it. Does that mean it's busy work? No, that actually means it's improving your understanding of the material. Do the work. Okay? Kind of makes sense? Questions about any of that? Exciting, right? Yay! Okay. The next thing we'll kind of mention, just to give you an idea, exam scores usually for every single course out there start high and they go lower throughout the semester. Okay, usually for 130 it starts high, goes low, and then it goes back up. Okay, why would it do that? Why would the second exam be lower? What's that? It is possible people are getting burnt out. You spent a bunch of time preparing for this first exam. God, I want to do well. I want to do well. Okay? You did well. You're like, well, great. I didn't have to work that hard. Most of this was review. You didn't spend 4 weeks preparing for this exam. You spent 8. Okay? Or 18 years preparing for this exam. That means the second exam, when it comes through, in just 3 weeks, 4 weeks, okay? You only have 4 weeks to study for it, not 18 years. You have to work at least as hard, if not harder, for the second exam to maintain. Okay? So do that, it doesn't matter. The scores will go up. Prove me wrong, please. I love being wrong, particularly when it comes to grades, because I'm a horrible pessimist. Okay. Prove me wrong and show all of those grades slide higher. Can we do that? Yeah. Exciting. Rah, rah. Go team. Okay. Which gets us to actually new content. Ionic charges. Okay, this was something that we kind of left out of the last one. Okay. And so actually on your exam there is a question that asked about ionic charges, and I have to go back and check because I'm not sure I actually added that extra point back in. So all your scores may go up by 2 points for that multiple choice question. Okay? So ionic charges. Okay, this is coming from a couple systems out of this. It's really coming from this word isoelectronic. Iso meaning same, electronic meaning electrons. So we're just saying we have the same electrons. Right? Why could we not have the same protons? Why could two elements not have the same proton? They'd be the same element. I can't change the number of protons because that changes the identity of the element. Okay? So our isoelectronic is talking about changing the outermost aspect of our atom. Okay? Well, what is it going to change to? Okay, well, it can change to a lot of different things. But there are certain groups of elements that have very characteristic charges, or very characteristic ionic charges that come out of them. Okay? Those are shown on the periodic table, or shown on this periodic table, okay? With some kind of glaring weird things within it. For some reason, the textbook thought it was a good idea to tell you the charge on tin. Don't memorize that. Same deal for lead. Also not worth memorizing. Okay? At the same time, they put things on there that you shouldn't memorize. They didn't put things on there that you should memorize. Zinc cadmium, and silver you're also required to memorize. Zinc will carry a +2, cadmium will carry a +2, silver will carry a +1. So remember how we had the names of the elements on flashcards and the symbol on the other side? And I said when you do that, you may also have to add some extra information. There it is. Add the charges to that memorization. You are required to know those charges. Right? That is now memorizing a bunch of facts. This is not just the number, but also the charge on that number, because some of them are positive and some of them are negative. I would make the argument that I have memorized none of these, and yet I'm a chemist, relatively successful-ish chemist. How could I get away with not memorizing them? I need to figure out some kind of pattern behind this. Why are they these charges? Right? How many of you, if somebody, a fairy godmother came down, or father, depending on your preference, came down and said, not even a baseball bat, just said, magic wand, poof, you are now in the nobility, with all the accoutrements that come with it. And you have to say accoutrements because it's nobility. How many would be like, yep, do that? You'd be like, no, I would prefer to live my life the way it is. You're like, well, there's responsibility. No, stop overthinking this. But the accoutrements that come with the nobility. What are the things that come with the nobility? Poof, castle. Poof, hundreds of acres of land. Okay. Poof, all the people to take care of all that crap so you can just sit there and be awesome. Okay. A fantastic flowing robe. Okay. A scepter, a crown, stockpiles of gold and money and wealth. You're just going to be like, no, I don't want any of that. Okay. Probably all of you are going to be like, yeah, I think that's actually a pretty good deal. I think I would accept that. Okay. Our equivalent would be someone comes by and says, here's the winning lottery ticket. You can have it. No. I don't have it. I heard there was a curse with winning the lottery. Like, I don't want all that money. Right? That's not going to happen. Okay? So we would like that. Okay? Not only do we like it that much and willing to accept that, what do we do with our outward appearance every day? How many of you have cell phones that are worth probably more than anything you're wearing? Ooh. Why are you spending money on a cell phone when you could be spending it on, say, food? Okay. Nicer shoes, because when you walk, you got to walk on your feet all day. Okay. Your health. Why are we doing that? It's a status symbol. Okay. I've got the latest fancy iPhone 11. Ta-da! I must be a millionaire and so cool. It was like, oh, wow, how'd you get that? Because I made it up. It's a cardboard box. Okay? We want that. We try to show that to our outside world. Guess what our elements are doing? The exact same thing. They are changing their outward appearance to look like the nobility. But we don't have any kings and queens on the periodic table, do we? We don't have any kings and queens, but we do have the section known as the noble gases. Why were they the noble gases? They didn't react to anything. They were the higher level. Right? So what are all of our elements trying to do? Just like us, they are trying to look like the noble gases. Take a look at fluorine. Right? That upper right-hand corner. Fluorine wants to look like a noble gas. What are the noble gases near it? Neon, okay. Are there any other noble gases near it? There's helium. There's argon, right? Okay. I would make the argument krypton and xenon are too far away, so let's not worry about those. Okay. What can fluorine do to look like the noble gases? What does it have to do to look like helium? Remember, what can it change? Can it change the protons? No, because then it's no longer itself. Okay, we've lost that identity. What can it change?
The electrons?
The electrons. How many electrons does fluorine have naturally? In its neutral state, it has 9. Whoops, let's make that in red because we've got our fluorine. 9. How many electrons does helium have?
2.
2. So to go from 9 to 2, what does fluorine have to do?
That's the lose electrons?
How many electrons would it have to lose?
7.
Good math. I thought it was 5. Seriously, I'm not kidding. I don't know why. Fluorine to neon, what would it have to do? How many electrons did neon have? 10. What has to happen to go from fluorine to neon? It has to gain 1 electron. To go from fluorine to argon, well, how many electrons does argon have? 18. What would it have to do? Gain 9. What is the easiest thing for fluorine to do? Lose 7, gain 1, or gain 9? Gain 1. So what happens? It gains 1 electron, because that's the easiest thing for it to do. If it gains an electron, what happens to its charge? We added things to it, of course, so what would its charge become? Why is it becoming negative? We said we added something. We're adding an electron, which is negatively charged. Fluorine carries a -1. It's trying to look like neon, because it's the closest noble gas. Right? If we went through and tried to do this less messily for chlorine, we'd be going from chlorine being 17 to neon at 10, argon at 18, krypton at
36.
What's the easiest thing for it to do? Gain 1 electron to become argon. So what does chlorine do? Carries a -1 charge in its ionic state. Really? That's how it works? Yeah. Yeah, it's actually kind of neat. So let's pick something else. Let's pick sulfur. That's too close. Let's pick phosphorus. What are the noble gases close to phosphorus? Argon, xenon? I'll go krypton. Oh, you said krypton? Okay, sorry. That's my bad. And neon. How many electrons does phosphorus have? 15. How many electrons does neon have? 10. Argon?
18.
Krypton.
36.
To go from phosphorus to neon, what would you have to do? Neon. Lose 5 to look like argon. Gain 3. Krypton. A lot of math that's not a small number. 21? Yeah. What's the easiest? Going to argon. Gain 3. What happens to its charge? Becomes -3. The charge is buried in the periodic table. You just have to know how to read the periodic table. Okay? Why do we not look at, say, carbon? Notice carbon isn't on this list. Carbon to helium, carbon to neon, carbon to argon. Carbon has how many electrons? 6. How many does argon have? 18. Neon? Helium? So 2, right? For carbon to look like helium, what has to happen? Lose 4 electrons. To look like neon? Gain 4. Which is easier, losing 4 or gaining 4? It's right in the middle. I have no idea. It's one of those. It's either of those. It's any of those. What does that mean? Carbon doesn't have a consistent charge, which means carbon, you're not required to memorize. Right? You can do the same thing with the alkali metals and the alkaline earth. The exceptions that will come out of this, okay, as far as using this pattern to figure this out, would be your zinc, cadmium, and silver. Which is why I would say with those three, you should just straight up memorize. Don't worry about trying to figure out some pattern. You theoretically could. It's not worth the effort. +2, +2, +1. Anybody notice anything that could help you memorize those? Try and do it with the group
1B
number.
and 2B.
Okay, 2B and 1B. That could help out, right? 2 and 1. That works. Within a column, what does it mean? What happens to the charge? Stays the same. So if you know zinc, you know cadmium. What happens as we move across the table? Changes by 1, right? What happens when we move from cadmium to silver? Changes by 1. Okay? Kind of makes sense? Those of you wondering, I hope I never have to do that again. The entire chapter 6 requires ionic charges. Okay? So you need to be able to determine the ionic charges quickly and swiftly. And I don't know why I said that twice, but I did. Because those are synonyms. Okay? Compounds and chemical formulas. Okay? Just kind of a quick review. This structure some of you may need right now. It is the structure for caffeine. Right? And it looks a bit busy. It's difficult to process all those individual pieces. For those of you drawing it, stop drawing it. Okay? So what we might do to simplify that is say, let's hold off on looking at big pieces until a later section in your chemistry learning, and instead focus on just the components that make it. So I could go through and rewrite that thing, that it's composed of carbon, hydrogen, nitrogen, and oxygen. Well, how many carbons are in that structure?
8.
I got 8, so we're going to run with that. How many hydrogens? 10. Nitrogen? 4. Oxygen? 2. Let's do. Oh, someone said 3. Dang, I only got 2. I still only have 2. To fix that, we won't even look at it. That's what you're then responsible for. So you're responsible for looking at a formula and saying, what does that mean? So when I look at that, that 8 means I have 8 carbons. That 10 means I have 10 hydrogens. That 10 does not apply to the carbon. It only applies to what is directly in front of it. That's how that subscript works. Okay, kind of makes sense? So if we went through and looked at other compounds, we've seen other formulas before. You may see those change around in their shape. H2O is probably a bit excessively common. Okay. We could look at C6H6, O6 as another formula. C2H3O2. Why does that one look weird?
2 H's.
I have an H in front and an H in the middle. Why would I do that?
Because the hydrogen is bonded to the carbon.
So there's an interesting idea. Maybe the hydrogen's bonded to the carbon. Unfortunately, no. It's not a bad theory. I like it. Okay. Why is the H pulled out front? That H's chemistry is different than the other ones. Because it is different, I'm trying to highlight it as different, so I'm putting it separate from the rest. Okay. What's happening with the last one? Or C2H5OH? Why is the H not pulled into the middle? It's again, the chemistry is different. And in this case, back to James' idea, we're saying that H was bonded to the C because it's closer. The H here is bonded to the O because it's closer. So sometimes our formula is just saying, it's different. Other times, it's different and it's bonded there. Our formulas are very misleading as far as what they mean behind their structure. So don't stress on the meaning behind the structure, stress on the meaning of what's in it. So when I look at this compound, how many hydrogens are there?
Four.
4. When I look at this compound, how many carbons are there?
2.
2. That's what you need to get out of it. Make sense? I don't care necessarily where those things are connected. Okay. What then happens in chemistry? Well, now that I have compounds, I can react those compounds with each other. I can take a molecule of hydrogen and a molecule of water, and if I smash them together with a plus sign, meaning I add them to each other, I can make, there's my reaction arrow, water. Okay. So we have the basic pieces of how we manipulate our formulas to go through and make these things. Okay? It is those basic components that you need to be able to recognize and see. Some of you may have been pointing out that this formula, this equation, doesn't quite make sense. Maybe. Is that what we were suggesting? What's the issue with it?
Well, I don't know. Like, I didn't really know what happened to the 2 oxygens. Really.
Yeah, it says 2 oxygens, and I only ended up with 1 here. Okay? There's a problem with my equation. Okay? It is unbalanced. Is that something we will have to worry about in this unit? Yeah. Okay? But not yet. Okay? Before we get into that, what we'll do is take a step back because I tried to set up the play pause it videos to run over the weekend. Okay? So you have 3 videos that you need to watch, okay, for this unit. One is horribly long on naming. Okay? If you've watched it already, you can vouch. That's horribly long. Okay? Naming is a painful subject to get through. It just is. You need practice. Okay? Anybody have the lab manual handy? Okay? Take a look in the lab manual. Lab 6. And lab 6, if it's lab 6, is all about naming. So if you need practice with naming, go to lab 6 and just start doing it. Will you have to do it eventually? Yes. Okay? So get a jump start on it. Okay? So before we get there, though, we'll go through some kind of other things that are kind of a review for calculations. Okay? And in particular, significant digits being the big one. Okay? As was discussed last week with measurements in lab, your measurements will always come out with a number and a unit. One of the things that we'll find as we continue to move through chemistry is that it's not just a number and a unit, it's a number, a unit, and a substance. Okay? 200 pounds. 200 pounds of what? It's 200 pounds of gold. I'm going to have a slightly different interpretation than 200 pounds of bear. Okay? That's a significant difference. I need the substance listed. Okay? So, the types of measurements. We have distance or length, mass or weight, volume, and time. Okay? When we look at those systems, and this is one of the challenging things, is that because these basic measurements are so old, every culture or civilization that ever made an observation about this, because all of these are man-made inventions, has stamped their unit system to it. So when I went to measure distance, I said it was snapdragons. What the hell is a snapdragon? Well, I don't care. I know what a snapdragon is. If we want to now communicate about what a snapdragon is, we now have to sit down and come up with a way to convert snapdragons to... What do you want to convert them to? Feet, or inches, or centimeters, or meters. You need that conversion system. Okay? Which means you need to know what those are, which means you would need to memorize all that content. Okay? Or you look at the front of the exam. Okay? Same deal with mass, volume, and time. For the most part, where we tend to sit is in the metric system, because the metric system uses the powers of 10 to interconvert between individual measurements, which is a beautiful thing because we have 10 fingers. We can do multiples of 10 really easily. Okay? The American system does multiples of 2. Yes, we have 2 fingers, but going through and doing things by halves is not the most fun. Right? The power of 10 gets a little bit more refinement behind it. When we look at mass, mass and weight are not interchangeable. There's a variety of ways to measure mass. Okay? Weight is based off of gravity. Mass is an inherent property. If that confuses you, I don't blame you, but don't worry about it because it's not that big of a deal, even though I just recorded that into the video and I'm sure someone can yell at me about that. Okay? This little link actually goes out to a cool little video, I think, personally, about a kilogram. You get a guy super excited about a silver ball. Okay? It's neat, but we're not going to watch it. Okay? Volume measurements, we're not going to watch it in class. Volume measurements. Okay? Mass is great for solids, but when I get to a liquid, if I pour a liquid onto the balance, it just spills around it and potentially destroys my balance. Okay? I could put a container there to trap it, and that can help. Okay? But I found that it is easier to measure liquids by volume. There's a variety of ways to measure liquids. Okay? Graduated cylinders, syringes, burettes, pipettes, volumetric flasks, beakers, Erlenmeyer flasks. Okay? Pretty much any container is a way to measure a volume for a liquid. Okay? Now we get into the fun part with our measurements and our uncertainty. Every measurement includes all of the absolute numbers. That's what I've been calling it. For those of you in Thursday, what did Dr. Guo call them? She didn't call them absolutes. Okay, so you decided to block that out? Okay. She called it something different that I actually kind of liked. Okay, so when we look at this rod, what is its length? 4. Okay, there's the length. Is it exactly 4? No. So give me something else. 4.2. Give me something else. 4.6. Okay, I'll accept that. 4.20. Is anybody going to tell me 3? Why not? Because, dude, it's obviously higher than 4. Yes. Okay, that 4 is an obvious digit. Okay, that is an absolute. Is anybody going to tell me 5? No, because it is obviously less than 5. Okay? So all of the obvious digits get written down. But if I only say 4, I lose some information because I can clearly tell that that is longer than 4. So I'll make a guess. I will guess one more digit, one more numerical place. So in this case, I'm in the ones place. I will guess the tenths place. Okay? Someone said 4.20. What is happening with 4.20? Why is 4.2 different than 4.20? Okay? 4 is an absolute, so that's fine. 2 is a guess. What is 0? It's a guess on a guess. So really you're saying you have no clue, you're just making up numbers. Yeah. That's bad. You can't do that. You can't include that 0. Okay? So your absolute plus 1 guess. That is your measurements. This becomes less important in lecture because how many measurements do you take in lecture? Exactly 0. Okay? But what you are required to use is the measurements that I give you, and you have to manipulate those measurements. Okay? As far as the lecture goes. So let's just jump to this next part. This is now introducing the concept of significant digits. Okay? So I've now taken a measurement, 4.2. Okay? That then says the 4 and the 2 are significant digits. And when I go through to run a calculation, I can't lose that information in the process of this. Okay? If I said it was 4.0, I don't want to drop that 0 because I'm now losing information. I took that 0 as a measurement. Okay? This is our significant digit issue. Okay? So if we take a look at these numbers, let's see how good we are now because we've had the lab to practice on this. We'll start with the first one. How many significant digits? Not all at once. I mean, it's overwhelming.
1, 2, 2.
Is everybody like, yes, I agree, thank you, Mike, that was dumb, let's not talk about this anymore? No, okay, so we've got some questions there. What is changing in each of these? Okay. All of these, you should be acknowledging that the digit 1 through 9 is a significant digit. So if I go back through and underline the significant digits, all of those have at least 1. Okay. In that first number, the 0 is not a significant digit. But in the next one, it is. And in the next one, both those zeros are significant. In the next one, only the last 0 is significant. And in the last one, none of the zeros are significant. Okay? And the issue stems from the meaning of 0. 0 carries 2 meanings. Placeholder, don't put a number here, or don't put a number between 1 and 9 here. Okay? And while that may seem like a similar concept, they mean drastically different things. Because what this is going back to is looking at a number line. Where this position is known as the ones, tens, hundreds, that says hundreds. This is where it's going to get really bad. Thousands. 10,000s. Just trust me. What's this one? Tenths. Hundredths. I can get the last TH out of that. Okay. So a number line with all those places, we could now look at that. Okay? And that can help us identify what's going on with it. And if every time we wrote down a number, we included the number line, okay, we would simplify things. Except you'd have to draw a number line every single time. And how many times when you write down a number are you putting lines under every single digit? Oh, you're not. Okay, why? It's insanely tedious. That's the point of the significant digit rules, is to really draw attention to where you are placing those digits. Okay? So a 0 in one of those locations just means don't put your number in the ones place. For that very first number, what that number means is that the 1 belongs in the tens place. What belongs in the ones place? Well, I don't know. Something. I literally have no clue. Okay? So that number in our number line would be the equivalent of this. 1 in the tens place and then something there. I have no clue. It's a question. How about the next number? Well, there's my number line. I want the 1 in the tens place. And then what do I put in the ones place? 0. Those two values have different meanings. The first one could be 10. It could also be 19. The second one means 10. Okay? The 0 in the first case is a placeholder. Don't put a number here because I don't know what it is. In the second one, the 0 holds meaning. It is not the number 1 through 9. Okay? That is our significant digit rules. So if we go through and look at our full set of rules, it's all going to come down to looking for that decimal point. That's what's going to define this. So rule number 1, 1 through 9 are always significant. Okay? If there is no decimal point, then the 0 must be controlled by not even numbers, by significant digits. It's a better way to write that. Or sigfigs, because it rhymes better than, well, actually sigdig is. Sigdig? No. Sigfigs. Sounds better. Okay. To the left and right. At any place to the left and right, doesn't matter. If that is true, then the 0 is significant. If there is a decimal point, okay, then a 0 needs to be immediately preceded by a significant digit to be significant. So if we go through and look at our numbers, 1 and 2 are significant. So now the question is that 0 significant? Well, to answer that, I have to look at rules 2 and 3. Okay? Rule 2, no decimal point. Is there a decimal point in that first number? No. So what does that mean? Rule 2 is the valid one. The 0 must be controlled by sig figs to the left and to the right. So I'm going to go from that 0 and look to the left. What do I have? I have a significant digit. I look to the right, what do I have? Another significant digit. The rule is true, that makes the 0 significant, and I have 3 sig figs. What about the next number? The 1 and the 2 are significant. Do I have a decimal point? No. Rule 2. Must have a sig fig to the left and to the right. Do I have one to the left? Do I have one to the right? No. Is that a significant digit? No. How many sig figs? 2. Do the rest. If you got questions, raise your hand. I'll come to you. 4. 2 sig fig, 2 sig fig, 2 sig fig, and 3 sig fig. Okay. I've got 4 starred because in walking around those were 4 that were consistently either goofed or confused something else. Do you want me to look at any of the others?
Can you look at
The 0 point
no, the one under?
down here? I've got it starred. We'll look at it. Oh, yeah. Both those are starred. All right. Let's take a look at the left. 120 decimal point. So apply the rules. 1 and 2 are significant. Because there is a decimal point specified, not implied, specified, I will go to rule number 3. The 0 needs to have a significant digit in front. Does it? Yeah. 2 was a significant digit. I underlined it, which then means the 0 is significant. 3 sig figs. Right? How about the 1 underneath? Well, the 1 and 2 are significant. Again, I have a decimal point specified. So I look at that first 0, look to the left. What do I have? A significant digit, which happens to be 2, but that's kind of irrelevant. It's a significant digit, which then means the 0 is significant. I look at the next 0 and I look to the left. What do I see? A significant digit, which happens to be 0, but again, irrelevant. I've already specified it as a significant digit, which then makes that 0 significant. 4 sig figs. Right? When we move to the right-hand side, the 1 and the 2 are significant. For the decimal point, if there's a decimal point, I need to have a significant digit immediately to the left. That first 0, sorry, I lost track of it on my screen. Is there a significant digit there? No. So is that 0 significant? No. How about the next 0? What's immediately in front of it? A non-significant digit, which means not significant. Okay. Last one. Again, decimal point. What's to the left? Nothing. Not significant. What's to the left? A non-significant digit, so not significant. 1 is significant. 2 is significant. Immediately to the left of that 0. Significant digit, and I get 3 sig figs. Okay. These rules, in my opinion, are easier to follow than what the textbook outlays with, I think, 5 or 6 different rules. If you prefer the textbook, then use the textbook. It really doesn't matter. You'll get to the same answer. Okay? So why do we, almost why do we care? We'll bring in one last issue here. Measurement versus exact. Okay? Distance, mass, volume, and time are only as accurate as the instrument measuring them. Are there measurements that don't require an instrument? How many pens am I holding? 1. So if I wrote that down, I would write down 1 pen. Okay. What that means, according to our standard rules of measurement, is that I have 1 in the ones place, followed by I don't know in all of those other places. That's what our standard rule of measurement means. Okay? Is that true? Is it possible that this isn't 1 pen, it's 1.9 pens? No, it's a single pen. So that's not a question mark. I know that's not a 9. Could it be 1.8? No. What does that number have to be? 0. I know that to be true. So it's not a question mark. It's a 0. How about the next one?
0.
Also a 0. And the next one? So how many significant figures are in that observation, if you will, for 1 pen? Okay. There is an infinite amount of sig figs in that. Not 1, an infinite. Okay. Does that mess with your head? Probably.
Wait, why is there anything?
Okay. In this measurement of there being 1 pen,
Yeah.
okay, according to our measurement rules, that would be 1, I know that value, decimal point, I don't know what the value is, I don't know what the value, I don't know the value, I don't know the value. That's our standard rule for a measurement. So this could be 1.9 pens.
But it's just 1.
So it's not 0.9, is it?
Yeah.
What is that point?
It's,
0.
yeah.
Right? So 1.09 pens?
It's just 1 pen.
It is just 1 pen
With nothing else behind
with
it.
nothing else after it. But if we look at that observation or that measurement, it appears to be 1 sig fig. It's not 1 sig fig. It's an absolute truth. There is exactly 1, which means it has an infinite amount of sig figs. Does this show up in other cases? How many inches are in 1 foot? 12 inches equals 1 foot, right? How many sig figs? Sorry, that's really small. This is an infinite. How do I know this to be infinite? This is not a measurement. This is a definition. This is an exact thing, which means those numbers have an infinite sig figs. And with that, we'll stop.